Hello, everyone. Thank you for standing by. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Amy Hyde, editor of Pumps and Systems Media. Welcome to From Reactive to Proactive, Predictive Process Observation Maintenance Strategies for 2024, sponsored by LJ Star Incorporated. Our presenter today is Scott Klutzer. Scott is the Director of Business Development at LJ Star, a leading manufacturer and supplier of process observation, sight glass, and sanitary fittings. With over a decade of experience in industrial process observation technology, Scott is a recognized expert in the field. Scott works closely with clients to understand their unique needs and develops customized solutions that meet their requirements. His dedication to providing high-quality products and services has helped LJ Star build a reputation as a trusted partner for process observation equipment. At this time, it is our pleasure to begin the webinar. Stay tuned after the presentation for the live Q&A session. Please send your questions at any time through the Ask Question box located on the bottom of your screen, and we'll get to as many of those as possible. Now I'm going to turn it over to Scott to begin the presentation.
Welcome, everyone. My name is Scott Klutzer, and I'm the Director of Business Development with LJ Star Incorporated. For those of you that aren't familiar with LJ Star Incorporated, we're an industry leader in supplying process observation equipment such as sight glasses, lights, sanitary fittings, level gauge instrumentation, and camera systems, as well as a handful of other products. We also own a company in Springfield, Missouri named Tank Components, and they are a supplier to the tank manufacturers across the country with regards to products such as tank heads, manways, sanitary fittings, and cylinders. Basically everything the tank manufacturer may need to build the tank and sell to their end users. With regards to the presentation today, we're essentially going to look at two fundamental approaches to maintenance management, such as reactive and predictive maintenance. We're going to kind of look into the definitions, the advantages and limitations of each, and we're going to start to look at a little bit of how artificial intelligence is revolutionizing what companies are doing and how they are using predictive maintenance along with the AI to determine what needs to be replaced and how to keep their equipment running efficiently. And again, this is going to be an introduction to reactive, predictive, and a little bit of AI. But certainly, when we're done, hopefully you'll have some questions, you'll have learned a little bit, and maybe in the future we'll be able to go a little bit further. The first part we're going to get into today is understanding reactive maintenance. Essentially, reactive maintenance is a strategy where maintenance activities are triggered in response to equipment failures or malfunctions. So one of the ways to think of it is it's essentially putting out fires as they arise and addressing issues only after they've caused disruptions in the operations. Some of the characteristics that you'll see tied to reactive maintenance would be they're unplanned. So your facility is going to be performing repairs in response to failures or breakdowns. Now these can be sudden. They're unplanned. You don't see them coming. Also costly. I know that dealing with my customers on a day-to-day, we get a lot of emergencies, especially in the oil and gas industry. So what you're going to have is these are emergency repairs because they're unexpected. So you'll have to pay for expedited shipping. You'll have overtime labor costs getting maintenance to get into the facilities and get those repairs completed so they can get the equipment back up and running. I can't tell you how many times I get a call at the office and I'm told that we have to have it shipped next day air for Saturday morning delivery, and we have to have somebody out, and I'm sure they're getting paid overtime to do that. One of the bigger things is downtime as well. It's unplanned. So you don't have a schedule for the disruption. You've got delays in getting product to your customers because you have time that you can't account for because the equipment's down. And again, it's reactive. So it does lead to a culture of repeated breakdowns and ongoing reliability issues if you're not taking care of the equipment the way that you should be. Now, you may be asking yourself, why are we discussing a maintenance strategy that seems to be inherently flawed, such as reactive, where you know the equipment's going to go down, you know you may have issues? Well, reactive maintenance does have a time and place, and there are positives that can be tied to it. And what you'll see on the next few slides is we're going to kind of go over reactive, we're going to go over predictive, and we'll talk about the positives, the negatives, and then kind of give an overview. But first and foremost, reactive maintenance does offer a swift response to an unexpected breakdown. So when a piece of equipment fails, whether it's due to wear, tear, unforeseen circumstances, that reactive maintenance allows us to spring into action immediately. So it makes it very simple. The only goal is that piece of equipment's gone down. We're going to do what we can to get that piece of equipment back up. And there's no need for any type of elaborate predictive models. There's no extensive planning. We just address the issue head on. Also, with regards to being cost effective, it does make sense because reactive maintenance requires a minimal upfront investment. And you'll see what those investments can be when we talk a little bit about the predictive technologies, investing in AI, and some of the preventative measures. This can come in handy where resources are limited or where equipment failure consequences are relatively low, as each company would need to look at it. If you've got equipment that you don't think is going to fail very often, reactive maintenance may be the way to go because the costs can be kept relatively low. It also allows organizations to allocate the resources where they're needed most urgently and prioritize critical operations. So it does give you some flexibility with regards to what you can do and where you're allocating your resources. And it does finally allow you to prioritize where your maintenance efforts are on equipment. So you can, instead of when you've got a bit of a predictive model, you may have upcoming shutdowns, you may have allocated resources to those shutdowns already, whereas reactive, you're basically prioritizing your maintenance efforts on any of the equipment that's been directly impacted within your operations. You don't already have crews allocated to other areas that may not be able to get onto these critical assets. So there are positives tied to the reactive maintenance. However, let's be honest about the drawbacks of reactive maintenance because there are many of them. One of the most significant challenges we find is the high downtime associated with it. So when equipment fails unexpectedly, it's going to grind your operations to a halt, resulting in lost productivity and revenue. Also, one of the biggest things is the costs incurred in repairing or replacing equipment on short notice, because as I mentioned earlier, I have customers all the time calling in emergency situations, hoping that the equipment is on the shelf, ready to go in 24 hours or less, and that we're able to ship it to them next day air. And that's not always the case, at least not with us. I mean, we try and stock as much equipment as possible, but we can't guarantee that a certain piece of equipment that's gone down or had a failure on is going to be available and ready to ship same day. And there's a significant amount of cost associated with that as well. When you're paying the expedite costs to have an employee go in the back and get that equipment ready, when you're paying for the hot shot or the overnight, or you're having one of your maintenance people actually on site waiting for that equipment to arrive, get the equipment fixed, it may be spending overtime, maybe paying those freight costs. There's a significant amount of cost associated with these issues. One of the other major issues, too, is there's an ever-present risk of safety incidents associated with this reactive maintenance. Always rushing to fix equipment under pressure can definitely compromise the safety protocols that the facility may have in place, putting both the personnel and assets at risk. So you definitely don't want to forget the potential damage to equipment caused by delaying maintenance until failures occur, which can escalate repair costs over time. And of course, another area that's going to end up costing you is productivity, because these unplanned and frequent equipment failures, they're going to disrupt your workflow, they're going to reduce your productivity, your efficiency within the plant, and it's going to delay product that you could be manufacturing to your customers, which leads to customer dissatisfaction. And that can hurt you more than anything. Now, with regards to reactive, it is essential to recognize that reactive maintenance shouldn't be your sole strategy employed. It should be complemented by a proactive maintenance approach, which we'll talk about later, by incorporating some preventative and predictive maintenance. So you've got kind of a balanced strategy. But there are companies out there that just don't have the funds up front to implement those preventative and predictive maintenance strategies. So while it does have its limitations, it is going to serve as a vital purpose in certain contexts. So you would have to go out and understand what your company's strengths and weaknesses are, and then determine what maintenance management practices are best optimized within your own operations and ensure that your equipment is going to be reliable. Next, we're going to move on to understanding a little bit about predictive maintenance. So predictive maintenance represents a bit of a shift from what many companies consider the traditional reactive approaches that we just discussed. So instead of waiting for the equipment to fail and reacting to the consequences of that failure, the predictive maintenance is going to leverage data and advanced analytics, which we may get into after the predictive discussion, such as AI, and it will use that information to foresee potential failures before they occur. It's a little bit like having a crystal ball for the machinery and allowing us to intervene and prevent the costly downtime and disruptions. And essentially at its core, the predictive maintenance is about harnessing the power of the data that you're going to have. So it's a very data-driven maintenance approach. You're going to collect and analyze significant amounts of information, everything from sensors that you may have in the facilities to visual observation, where you may be using equipment like LJ Star produces, and other sources where you can gain valuable insights into the health and performance of your equipment. And then what the AI does is it assists with the machine learning to sift through this data and identify specific patterns tied to your equipment that may signal impending failures, and then allow you to basically work around those patterns and those schedules and plan ahead so that you have equipment on site and you can schedule your shutdowns to make sure that the equipment is good to go. So again, the biggest thing is you're identifying potential issues through your visual monitoring, and you're using the technology to determine when those maintenance repairs need to take place. Now, there are significantly more positives than I can even list on this slide with regards to predictive maintenance. First and foremost, it's going to enable you to minimize your downtime by addressing issues before they escalate. And you want to avoid getting into those full-blown failures where you're going to have major issues. This predictive maintenance not only preserves productivity and revenue, but it also enhances the reliability of your operations to be prepared. So if you can picture, the goal would be to picture your plant, your facility, whatever it might be, to where you never have unexpected issues. Now, that's not going to be possible, maybe someday when AI gets so smart that it takes care of everything before anything can fail. But the goal is to basically make sure that as much of your equipment is functioning properly, is replaced and repaired when necessary, and you don't have any of that downtime. Also, it allows for optimizing resource allocation, which is extremely important. Small companies that can afford to go with predictive maintenance, where you may have smaller staff of people on the floor, it's good to be able to prioritize those activities based on the actual equipment conditions, how much personnel you have on the floor. You can avoid any unnecessary preventative maintenance tasks, and you can make sure your resources are allocated properly to where they're most needed. It's not only going to save time and money, but it also prolongs the lifespan of the assets that you have by preventing any type of premature replacement or repairs. You don't want to replace components on equipment too soon, because as a company, you want to get the most out of that equipment and make sure that you're optimizing your expenses as best as possible. And another area is safety. With Predictive, it enhances safety in the workplace by proactively identifying and addressing potential equipment failures. By preventing those equipment failures, we can mitigate the risk of any type of accident or injury caused by malfunctioning machinery, where personnel is actually working with that machinery, creating a safer environment for the employees on the floor and reducing liability for our organizations as a whole. Also, one of the biggest and most importantly important items with regards to predictive maintenance is in terms of cost savings. So we've kind of talked that there are quite, and again, the cost savings are again going to be tied to things like reducing maintenance costs, downtime, all those things. Now there is a significant amount of upfront costs. So we're talking short-term and long-term when we're talking cost savings here. But in the long term, I would say it's a game changer as far as cost savings, because you're going to prevent unplanned downtime. You're going to reduce those maintenance costs. You're going to optimize the asset performance of the equipment that you have on site, and you're going to predict the maintenance of the product that you have on of the material, or well, of the equipment that you have on the floor. Making sure that everything is ready to go and driving that operational efficiency and competitiveness within your company. Now, while there was a significant amount of positives tied to predictive maintenance, there are some negatives that do need to be taken into account. And again, with predictive, I think you're looking at a lot of short-term, long-term when you're comparing your positives and your negatives. But one of the first things that comes to mind is it's going to require a significant investment in the technology and the infrastructure upfront. So there is a significant upfront cost. Now, as mentioned on the positives, the upfront costs, once you get through those, you should get that investment back relatively quickly in the savings that you're going to have from everything that you're going to get out of the predictive strategy. But there is a significant amount of investment in technology and infrastructure up front. The maintenance systems involves deploying sensors and data collection devices, and you're getting into advanced analytics platforms. And these upfront costs can be prohibitive for some organizations, particularly smaller businesses with limited budgets and limited personnel. So it does make a difference what type of company you are and what you're looking to do and whether or not this is a good fit for you. Also, predictive maintenance relies heavily on data accuracy and reliability. So if the data collected is incomplete or inaccurate or outdated, the predictive models may generate false alarms or miss critical failures altogether. So there is a dependency on data quality as far as what you're bringing back in. And there's a significant challenge there, because up front you need the system to learn what you're looking for, as well as you need the personnel on the floor to visually observe, as well as what the sensors and the data coming in is seeing. So you have to have both the system in place and the personnel in place to make sure that that information is accurate. It also introduces a level of complexity to the maintenance operations. While reactive is basically straightforward, you know what you're going to get. You know that a piece of equipment's gone down. You assign the personnel. You get them there. You're right on it. You know that you're going to get that fixed, and it's straightforward. And you're responding to those failures as they occur. But predictive requires a proactive planning and basically a planning period and an ongoing monitoring that constrains some of the resources that you have on site, requiring maybe specialized experts in certain areas, which may lead to additional training costs, skill development, and additional maintenance personnel that you didn't have to have with the reactive. There's another area that has come up, and I had this talk in some of the conversations I had leading up to this presentation, which is basically the risk of over maintenance. And I kind of thought about this when I was talking to my wife about our cars, because, for example, my car is a newer vehicle, and they recommend having the oil changed every 10,000 miles, but the mechanic requires the oil changes to occur every 3,000 miles. And my wife likes to stick to the more conservative, so now I'm paying for 3 oil changes where I should have been paying for only 1. So when we get into this this risk of over maintenance, to prevent failures before they happen, there is a temptation to perform maintenance tasks prematurely, and that can lead to unnecessary downtime because you're taking the equipment out of service to perform the repairs on the equipment. There's increased costs, like I said here, I'm paying $140 now for 3 oil changes when I should have only paid $140 for 1 oil change. And is there a benefit? So there's a need to balance that need for proactive intervention with the risk of over maintenance, and making sure that you're finding that fine line between when you should be repairing it and taking it out of service, and making sure that it's functioning properly, and how long that piece of equipment should be able to go. And lastly, there's also a risk of where it may not be suitable for all types of equipment or industries. So it's something that you would have to look at as a company and determine whether or not what's the criticality of the equipment. Maybe it's low, maybe making the investment in predictive technologies is unjustified. Maybe the organization has limited resources, where the equipment failures occur. Maybe the consequences of that may be minimal. So as a company, you would have to look at that. And then lastly, there's a bit of a cultural thing here as you're starting to see the different generations, whether it's the boomers, X, the newer generations coming up, younger, middle-aged, older, to where, a lot of the older guys are skeptical of the technology. Some of the guys some of the people in the middle are skeptical but accepting, and then a lot of the young people are over accepting and don't ask a lot of questions and just rely on the technology. So there's a little bit tied to the cultural portion of this predictive and relying on AI and computers and monitors, because I get a lot of the old school guys, and they love to be able to look through a piece of glass and see what's happening inside and determine what may be needed, instead of relying on basically a sensor that they can't see anything inside the equipment, and let that sensor determine what they're going to do based on a computer algorithm telling them that, hey, this needs to be done at this point in time. So there's a little bit of a cultural issue here as well. In the next section, we're going to review reactive and predictive side by side, so you get a little bit of a better idea as to what the comparison looks like. So as mentioned in the previous slides, this is basically a side-by-side comparison, so you can see some of the differences. So as far as definition, reactive is performed in response to equipment failure or breakdown, and predictive is basically to make sure that the equipment failure is likely to not occur, that we're going to repair it and predict when it needs to be replaced. And the goal of these is to, on a reactive, your goal is to restore that equipment to working condition after failure. You're going to wait till it fails, it goes down. It's pretty much similar to running on bald tires. You're going to wait until that tire pops, and then you're going to basically put it up on a jack and replace it and get that car rolling again. Whereas preventative is going to minimize your downtime by addressing those issues before they lead to failure. Costs, as we kind of discussed, cost is an interesting one. Again, you've got to look at your long-term and your short-term goals. You got to look at the way your company's set up, what you have as far as resources. But reactive overall can be costly due to unplanned downtime. So you're going to have emergency repairs, potential damage to equipment. You may have safety issues again. And predictive is generally going to be lower cost. Again, long-term, your upfront costs are going to be quite high, but your long-term your costs are going to be lower due to the planned maintenance, your reduced downtime, your less need for emergency repairs, less cost associated with that. And then as far as reliability, Reactive is usually lower due to frequent breakdowns and repairs. It's also not good for the equipment. You may be able to get the piece of equipment back up, but how much damage did you do long term to it, waiting till it went to failure? As well as predictive maintenance, it's typically higher due to proactive maintenance and early identification of potential issues. So usually that equipment is well taken care of. You're replacing components sometimes early to make sure that equipment continues running the way that it should. Same with these last few points. Your equipment lifespan, again, it may be shorter under reactive because you're basically your maintenance is leading to premature wear and tear because you're basically waiting for the piece of equipment to break down and then making the repair. Whereas your predictive is you're making those repairs before the equipment goes down or has any type of major failure, so you may not lose other components on that piece of equipment, and it's better maintained. Also, skill requirements is an interesting one. I do like to talk about the skill requirements because it is interesting with, again, lots of personnel that are retiring that have worked on equipment for years. Reactive, you do need skilled technicians for emergency repairs and troubleshooting, guys that have worked on the equipment forever and know it inside and out and how to maintain it. Whereas predictive, again, you can plan a little bit better for that. You still need skilled technicians, but they're different technicians at that point. You're talking about data analysts and people that are reviewing the AI data coming in that might be working on the probes and sensors and equipment used to predict how the equipment is going to work, and that gives you time to plan and bring people in specifically for those changeovers or shutdowns. So there's a little bit more time and people can take longer to react and prepare for. And then data. Reactive is very limited use of data, again, mainly for troubleshooting after something has failed, whereas predictive is extensive use of data from sensors and visual observation and other sources to predict how that equipment is going to function and when that equipment may need to be repaired. And what we found overall, talking to different companies, is that predictive generally leads to lower costs. You're going to find that it increases the reliability and there's less downtime compared to the reactive. So overall, while dealing with both reactive and predictive, each one does have their merits. Even though we're comparing, I can't honestly say which one is better for each company. Predictive does offer significant advantages in terms of efficiency, cost savings, and reliability. By being proactive, identifying and addressing potential failures, predictive maintenance does transform maintenance from a reactive firefighting exercise into a strategic asset management tool. But it is essential to recognize, though, that reactive maintenance still has its place in certain scenarios, like I said, where the criticality of equipment is low, where resources such as personnel or money is limited. Reactive may be the better solution for your specific company. And now we're going to cover a little bit of the role of AI in this predictive maintenance scenario. So AI plays a critical role in leveraging data to forecast equipment failures and operate and optimize maintenance schedules. And below I have a couple of the ways that is actually achieved. So with regards to data, there's just a vast amount of data from all sorts of sources. So you may have sensors throughout your facility. So many types of equipment are equipped with sensors that monitor various parameters such as temperature, pressure, vibration. You may have something that's monitoring electrical current. And these AI systems can collect that data from all these sensors in real time to monitor the health of the equipment. And any deviations from normal operating conditions can be flagged as potential indicators of impending failure. So, for example, we sell LED lighting, and we have had issues where electrical current coming into the facility is considered dirty, to where there's all kind of spikes. And For example, if there was a sensor tied to that, that sensor could determine why there may be a future failure because the light is not made to handle all those dirty electrical currents where you're getting those spikes constantly throughout the day that's putting strain on that particular piece of equipment. There's also the IoT, which are devices that are often deployed to gather data from equipment. These can be connected to the sensors and can transmit the data to AI systems for analysis. Now, this is something similar to a lot of the new cars that are being released where they are connected to the internet in some way, shape, or form, and they're sending the information that they're collecting to the cloud, and then from the cloud it's going to wherever you may have all this information coming into to actually be looked at. Now, with regards to the machine learning, these algorithms can be trained using historical data from within the facility and any of the equipment you have on site, and it uses that historical data to identify patterns and correlations between various parameters and equipment failures, and these algorithms can then be used to predict future failures based on real-time data inputs. So it's continuously learning. It continuously adapts and changes in its operating conditions and all the information that it's compiling over time. So it's when these systems are implemented in a facility in a new application, it's almost like starting with a 2-year-old and then moving to a 5-year-old and then a 10-year-old and then a young teenager and then an adult, and it just keeps getting smarter and smarter over time. The more information that it has coming in, the more information that it's learning. And nowadays, what you tend to find is there's a lot of companies out there doing AI for various companies, and they already have algorithms pre-built that they can use based on other companies of similar build. So you're not starting from scratch. You have something to start with. And then you start putting your data into that system, and that system continually learns and adapts and starts to understand what you need to have at that time. Now, with regards to something like an anomaly detection, to give you a real-world application, I know that AI has been making waves across industries. So from manufacturing plants to energy utilization, transportation, whatever it might be, but I've had some experience with it in utilities. So for example, predictive maintenance algorithms tied to AI can anticipate when a turbine blade in a power plant is likely to fail. And what they may see is a bit of an abnormal spin as the turbine blade begins to wear over time, at which point it would notify the technicians to replace it before it causes a catastrophic failure of the turbine. Now, again, when you start to get that anomaly, it's getting close to failure, but as that system learns, it will give you enough advance notice with regards to those anomalies that you can get the components brought in or shut the piece of equipment down before it fails and gets to that point. So that anomaly detection is pretty important with regards to the AI learning. With regards to scheduling, AI has the ability to handle complex situations. So traditional scheduling struggles with all kinds of variables and constraints, whereas AI is able to pull in large volumes of data, consider multiple factors simultaneously, and generate optimal schedules in a fraction of the time it would take a person to be able to do that. And that's taking into account conditions such as suppliers, time to get equipment in. They're able to determine future scheduling needs, how far in advance product may need to be ordered, and really maximize the ability to get equipment in on time and to schedule and to deal with different facets, to where you may be ordering 8 or 9 pieces of equipment, and within that 8 or 9 pieces of equipment, 6 of them are long lead, and it may not be something that was remembered, but as AI takes that information in and looks at that history and realizes, okay, we've ordered this part 7 or 8 times in the past, and of the 7 or 8 times, 5 of those it was late, and it was late by this amount of time, it's going to compensate for that lateness and make sure that you're getting everything on order in time. So it's able to take all that historical data, your current data, compile it all together, and then give you clean schedules for whatever it might be, whether you're putting personnel on the floor to maintain the equipment, whether you're ordering components for the equipment, whatever it might be. AI is starting to play a critical role in being able to put that information together in a very quick and efficient way for your personnel at your facility. Also, AI has been important in the area of cost savings because it's able to assist in everything from maintenance to on-site monitoring, to where it can detect signs of wear and tear, inefficiencies, abnormalities, and determine impending failure of equipment. So significant savings there. Maintenance and scheduling. Again, it's able to schedule maintenance tasks more efficiently. It helps to minimize downtime, reduce labor costs, maximize equipment uptime. Inventory management is a huge one right now. It's able to basically be able to predict when spare parts will be needed based on maintenance schedules, historical usage data. This reduces the need for excess inventory on site, which I know a lot of people like to try to keep the minimal amount of parts on site at all times, just to not have that extra cost associated with it. Workflow is another one as well. It's able to take tasks and free up maintenance personnel to focus on more complex or critical activities, determining on where they may be. So there's a significant amount of long-term savings that AI can play a role in, as far as again, helping reduce those operational costs, minimize any type of waste, and improve that resource utilization, which definitely helps free up time for others that you have in the facility. So I was trying to think of a personal AI usage that everybody could relate to, and I think the best way to do that is your personal car. I have a great example that recently my daughter was driving her friends and herself to Boston from Connecticut, and she gets about halfway to Boston and calls me because her check engine light's coming on. Now, mind you, before she went to college, I bought her a new car. Now, it's an older car. I mean, it's a 15-year-old car. So, in an older car, it's going to leak a little bit of oil no matter what. We had a brand new engine put in the car, and she calls me saying, check engine's on. I can't figure out what it is. So I say, hey, is it driving okay? She said, yes. I said, well, take it to a shop, have them scan it immediately like an AutoZone. Tell me what comes back. So she gives me the code. I check out the code, and it's talking about the oil mix, which leads to, do you have oil? So I had her get out of the car, go up front, pull the dipstick, wipe it off, check it. Lo and behold, she has no oil in the car. So she's definitely having a reactive moment here because she's having to react to an issue. Now, luckily, the engine did not overheat to the point that it was destroyed, considering it was a new engine. It would have been great if she was using predictive maintenance when it came to this, where she had been out maintaining the piece of equipment, observing whether or not there was oil in it regularly, like every couple weeks, making sure that there was plenty of oil in the in the car so that there weren't any issues. But it's a great example that you can relate to, because you don't want to wait and run your car with tires to where they're bald and waiting to basically explode on the car and then not have a tire and then replace it. You want to make sure that you're checking it regularly and saying, okay, the treads are getting low. I may need to take it in and get new tires put on before it gets to the point where I have a catastrophic failure either on the highway or on the road. You want to think of your family in that vehicle, to where your kids, your spouse, whomever it might be, is in that car. You want that car to be as safe as possible so that there's no incidents. So I think thinking of this as from the standpoint of your car, especially today, if any of you have newer cars, there's just so much AI that is put into these cars. Everything from driver assistance systems, where I think now you can hit cruise and basically have the car nearly drive itself other than you possibly steering. There's vehicles out there with autonomous driving, which would be fantastic. I can say that for sure. I would love to just be able to turn the car on and let it drive itself at some point. But you'll see everything from analysis where you have onboard information sent to a cloud, analyzed, and then sent to your phone. I know General Motors, for example, has an app that allows you to send real-time data from your car, letting you know when oil changes are supposed to occur, what the tire pressure is, what the fluids look like inside your car, and you get an update in your phone. So again, I even know on the General Motors app that it will schedule and notify you of a recommended maintenance appointment with regards to your car based on this particular app. So as far as cost savings, for the example I gave you with my daughter, it saved me from having to put another engine in the car. Luckily, she was notified before it got to a catastrophic point, which probably would have happened another 20 miles down the road. But the cost savings are fantastic from this new technology because it's going to reduce vehicles being in a shop. It'll lower those maintenance costs and improve safety and increase the reliability of the car and the longevity of the car. So some of the ways that future AI, as it continues to grow, will revolutionize our industries. There's several ways that I was able to come up with. I mean, the list is probably a significant amount of ways, but this is just some that would impact us overall as an industry. Again, the predictive maintenance, as we talked about, it'll continue to evolve and help companies predict equipment failures and again, help reduce those costs associated with those failures. Quality. What we're starting to see more and more is it's going to enable companies to do real-time inspections and quality control. So, for example, we have bottling lines where they have new high-speed cameras, and those high-speed cameras would be able to punch through thousands of bottles per minute and notice if one of those was missing a bottle cap and be able to dictate what occurs to that particular one, where it's at in that system, and pull that out automatically on some of these new production lines. And basically what that's going to do is improve product quality, reduce waste, enhance customer satisfaction because they're getting a better product. And then as far as process, it's going to be able to identify inefficiencies. Obviously, we have people at the companies that can do this, but it's going to be able to do so many more operations at one time and optimize that production and improve that energy usage and find those inefficiencies and talk to us to let us know how we can fix those. And as far as supply chain, that's a huge one. I think that one is probably one that's being used more than anything right now because it's going to allow us to manage our inventory levels. It'll allow us to route our products from our various suppliers. It'll also be able to identify possible supply chain disruptions, especially if you have a history of certain suppliers that always deliver late, for example. And how late is it? Are we talking 5, 10, 15 days? And AI will be able to determine, okay, this is our supplier, but we need to order X number of weeks in advance because they are always 5 to 10 days late. And another one is product design. It will be able to assist in facilitate in design, prototyping, reducing that product development time and reduce that time to market. So companies that are coming up with new products may be able to input some of the parameters tied to that new product and have the AI run in-house testing and reduce that time to market. So there's a lot of things that AI is going to be able to do here in the future. So essentially, in conclusion of this presentation, reactive maintenance is definitely familiar. It's often seen as a cost-saving measure in the short term, as we discussed. It does come with significant drawbacks, but has always been around. Because you're relying on a reactive approach means accepting that at some point the equipment is going to fail and the associated costs of unplanned downtime, emergency repairs, and lost productivity is going to be an impact. And I think in today's fast-paced and competitive business environments where every minute of downtime can translate into substantial financial loss and damage to your company, the reactive approach is simply no longer sustainable in most applications. Whereas predictive maintenance is taking a huge turn in the fact that it's being powered by AI now. Now, again, we're in its infancy. I think it's giving us a glimpse into the future where we no longer wait for equipment failures to occur before we take action. I think we're going to see a lot of companies start to harness the power of that data analytics and machine learning to anticipate these issues before they arise. I think those will lead to saving valuable time, resources, money. And I think the more information we put into these systems over the long term, the better predictive maintenance is going to get. And I think over the long term, it's going to get more and more less expensive than it currently is. So as LJ Star is a company that supplies visual inspection equipment, I did want to touch on a little bit of the visual inspection and just do a quick run through just to give you kind of an idea of what we can do to help, as well as show you one of the documents that we use when we're walking through a plant with maintenance or with personnel to kind of give them an idea. We don't make a recommendation, but we direct maintenance as to what to look for, and then they can make their own decisions. But with regards to visual inspection, you've got to understand on site what your components are. You got to identify your equipment and all the components involved that can be replaced, need to be replaced, may fail. And then as far as when you're going through your facility and you're working on your equipment, safety is always important. You want to make sure that you're taking your required safety precautions, make sure equipment isn't running, wear all your required PPE when you're on site completing these inspections. And then what we were talking about with the AI, there's visual versus sensors. Some applications on at the facility will require a visual inspection, such as, you may have an agitator inside of a tank. You want to make sure the agitator is running properly or the spray balls are running properly. And you may use some of our equipment to visually see into a process, or you may have an inline where you want to see that you have flow. And others, while others could rely on sensors that feed information to the company's internal network or control room. And you may also have a visual next to a sensor to make sure that the sensor is properly functioning. And then some of the stuff that we talk to is interpretation of the findings. So you've got to make sure that you have experts on site that understand the defects and abnormalities that may be found during the inspection. You may be using AI to help with those abnormalities or defects, and then what those abnormalities may mean for replacement or repair of the equipment. And then as far as troubleshooting and maintenance, importance of visual inspections within the overall maintenance programs is huge, as well as understanding the on-site equipment. That's one of the reasons why we like to come on site and work with maintenance to understand what they're looking at, what they're looking for, and what they need to understand with regards to the components involved in our equipment. And then as far as review, you always want to do an internal review with your personnel. Recommendations for future improvement, update any internal information tied to future inspections and maintenance. And on the next slide, I'll give you kind of an example of what we use just to kind of show you what we go through with regards to an inspection. So this would be a form that we would use, that we would write up when we're going out to do a visual inspection on one of our sight glasses, something very simple. So you can see how many different lines we have with regards to our inspection. So, we want to verify tag numbers. We want to look at the specification sheets to determine what materials are required for that unit. We're verifying whether there's leakage or evidence of past leakage. We're checking gaskets for contamination. We're looking at the glass surface. We're looking for whether or not there's scratches or chips or etches or anything along those lines. We're verifying the mounting flanges are flat, faced, and parallel. And we're taking photos of this as well. And, we're checking for gaskets, and we're looking at protective guards, whether they're missing or inadequate. You'd be surprised how many times I go out and the customer decided they didn't like the protective guards. They remove them, and it's not documented. We're looking for any type of cracking in the glass, any type of corrosion of the metal or the glass. We're verifying if the glass is etched or becoming opaque. And when we do this, we list the conditions, we list the locations, we make comments, we take photos, and then we supply these to the maintenance teams. And we walk them through how we go about doing this. And this is a visual inspection, or a sample of a visual inspection. And then this information is taken back and compiled with everything else that they're looking at to determine whether or not the equipment will have to be replaced. And a lot of this is tied to, as we talked before, predictive maintenance or proactive maintenance. So that's the end of the presentation. I personally want to thank everyone that stuck with it through the entire presentation. I think we have about 10 to 12 minutes of time left that we can take any questions that anyone may have. Certainly more than happy to answer any and all questions you may have, and hopefully be able to give you some good answers. Thank you again, and you guys have a great day.
Thank you so much, Scott, for that great presentation. We're going to get into the Q&A in just a second, but before we do, attendees, we have a question for you. It should be appearing on your screen now, and that asks, do you currently have a maintenance strategy? If you can just take a second to answer that for us, we'll give everybody about 30 seconds to do so. And attendees, while you're answering that, just a reminder, if you would like a certificate of participation for today's webinar, you can do so by clicking the View Certificate button in the bottom right box. And if you have any questions you haven't sent over yet, now's the time to do that. So just keep those questions coming, and we'll keep pulling them from the chat and putting them in front of Scott to get to as many as possible today. We'll give everybody just a couple more seconds. All right, great. So we're going to go ahead and jump into the Q&A, and I'll leave that poll question up if anybody else wants to answer there. But the first one, Scott, is if I was going to invest in one AI tool, which would you suggest I start with?
So there's quite a few different, everything from like Data Robot to GPT-4, Apier, and you can do your research online to see which one fits up best with your company, because they're not all necessarily set up for, say, manufacturing. There are some set up for different markets. With regards to manufacturing, I hear quite a few people talking about GPT-4 and Data Robot, but again, you'll want to research that. GPT-4 is something that's pretty easy. It can be applied across all kinds of different sectors, so it's kind of thought of as an easy one to start with. I know that it can be trained on vast amounts of data, so it can handle all types of complex queries and generate high quality responses. I know it's being used in various locations currently, but more or less, I would look into one of those, or do your research online, because there's so many. Just look at whether it's manufacturing or if it's healthcare or whatever your market is. Look up what your market is and what AI systems you should look at, and talk to various companies. I would definitely get a consulting firm to work with if you're looking at using one, and kind of look at the various ones that are out there now, and then make a decision based on that.
Okay, great. The next question says, if I don't have the funds to invest in a fully preventative strategy, where should I get started?
Probably the best place, if you can't go with that preventative, is to really take a look at your facility and start with regular inspections and maintenance. It's surprising how often I'm in the field and equipment's just not being maintained or inspected. So it helps to set up scheduled inspections, kind of establish a routine for the machinery as far as when you're going to go out and look at that equipment. Regular checks can definitely help. Creating checklists and visual inspections, kind of like the one that we showed at the end. And especially with the checklist, if you can create a detailed checklist for each type of machine, and I know it sounds kind of like a pain in the ass, but some of that equipment's extremely expensive. So if you can create those checklists for the different types of machinery that you have, and looking at what needs to be inspected and how you service that regularly, it goes a really long way. I would also try to establish some sort of a maintenance log. You know, it helps to keep manual records as far as when those maintenance activities occurred, what the repairs were, when the inspections were performed, and definitely track performance. Shouldn't be too difficult to track the performance, you know, as far as how long, you know, how many operating hours, what are your load levels, how much downtime does the equipment have? And then training and education is always a good one too, because if you're training your staff on what to look for, you're training them on how to operate and maintain the equipment, the better trained they are, the more proper usage the equipment has, you know, over the long term. And then basically following any of the manufacturer's guidelines. You know, how often do you want to replace gaskets or oil or internal lubricant that it may have, whatever it might be that the manufacturer is saying you need to do with that equipment. Just make sure that you're doing a lot of that.
Sounds good. We'll get to a couple more questions, but first, one of the questions that we've got here from Alan says, where can we learn more about your services? We've got Scott's information up on that main slide, but Scott, is there anything you want to add to that?
Yeah, I would say you've got my contact information, so that's always a good starting point. If you want to email me directly, I can get you all the various links to our website and what types of services that we offer. As mentioned in the presentation, I go out and do general inspections at the facilities with the maintenance teams and kind of walk them through what they need to be looking for, especially with our type of equipment. I can't obviously walk you around and show you everyone else's, but I can definitely do site inspections with regards to our equipment. And we do have a wealth of information on our website, from webinars to YouTube videos, to just about any type of white paper you can think of on our specific products that you can find on that website and that I can assist with as well. So I would definitely start with our website or email me directly afterwards or when you have time, and I can definitely get you set in the right direction.
Sounds good. All right, we'll get to one more. And attendees, if we don't get to your questions, we'll get those over to Scott and he can reach out to you offline. The last one we've got here is, what is the difference between a level gauge and a sight glass?
The biggest difference is how the equipment's mounted. So normally with a level gauge, it's mounted off to the side of the tank, and it's basically used to show level of a larger tank, whereas a sight glass might be used on a manway or on the top or even the side to view inside. So you may want to see if your agitator is functioning properly, or if your CIP spray devices are functioning properly during a process. You would use a sight glass. Whereas if you're filling a tank, if you have truckers coming in and you're filling a tank and you want to know what your level is, or you want to have your level as a backup to, say, a radar that you've got on a tank, you would use a level gauge, which again just falls off to the side and usually shows level compared to viewing what's happening inside the tank.
Sounds good. Well, thank you so much, Scott, and thank you to everybody for joining us today. Like I said, any questions that we didn't get to, we'll get those over to Scott so that he can answer those offline. Of course, we'd like to thank Scott and the LJ Star team. You can look for an email from us later today where you'll be able to access playback and presentation from this event. But please feel free to visit pumpsandsystems.com for more on this topic and additional educational webinars, including more from Scott. So thanks again to Scott and LJ Star, and thank you to everyone for taking the time to join us today. I hope you all have a great day.